Good day, guys. Let's see one last video on surface area for parametric equations. So it says we should calculate the surface area generated when the curve given by the parametric equations. We've got x equal to 3t squared and y equal to 2t cubed over the interval 0 to 1 rotates about the y-axis. So this is the part that is important. The rotation. When it comes to parametric equations, the rotation tells us how our formula starts, and the formulas for parametric equations are on page number 7. So I'm just going to look for AY formula, which is the integral from U1 to U2, but here our parameter is t. Then I'll get my 2 pi x, the square root of dx over dt, all that square plus dy over dt, all that square, then dt. So that's my formula. So that formula should now take me through, and we know very well that with parametric formulas, this x here, before we integrate, we must replace it by the value of x because the active variable is a t. So let's go. X is equal to 3t squared. I'm looking for dx dt now. Dx dt will give me 6t. Then next, I square it. If I square dx dt, it means I'm squaring 6 to get 36. I square t, I get t squared. So I'm done with x. Then I do the same thing for y. So our y is 2t cubed. Then we'll look for dy dt as the formula requires. I'll get 6t squared. Then we'll also square that. Square dy dt, it means we are squaring 6 to get 36. We square t squared, it gives us t to the power 4. So up to so far, we are done with the aspect under the square root. We just need to add the two together. So if we add dx over dt, all that square to dy over dt, all that square, it means I'm taking 36t squared plus 36 t to the power 4. But if you look at that one very well, you will see that 36t squared is common. So I will take out my common factor to get 1 plus t squared. So that is what I get. I can then recall my whole formula, substituting everything inside. So if I go to my formula for AY, T1 and T2 will just be 0 to 1. Then I get my 2 pi, my x, as I told you, will be 3t squared. Then I get the square root of, this is the item that falls under the square root, I get 36t squared into 1 plus t squared dt. So up to so far, anything that is not t will be a constant, so I'll get 6 pi going out. So I get 6 pi going out, the integral from 0 to 1. I'm left with t squared here. But you see that this is a product. The square root can flow freely over the product. So I get 36t squared multiplied by the square root of 1 plus t squared dt. And when you take the square root of 36, the square root of 36 gives me 6. The square root of t squared gives me t. Then the root of 1 plus t squared dt. So in this case, we've got another 6 that is going out. So that outside, we are now getting 36 pi outside. The integral from 0 to 1. Then t squared times t becomes t cubed. Or if you want, you can still leave it as t squared times t. Then the square root of 1 plus t squared dt. So this is how our problem ends. So this is still going to take us through U-substitution, but this is a special U-substitution because what we are familiar with is when this t squared is not there, then you will differentiate t squared to get t, where the power rule can help us. But if you look at what is happening here, you have 1 plus t squared here, but that is t cubed. So with this kind of U-substitution, I think it was done in N5, you must do it the same way they teach you U-substitution in N4, which means you must take u to be the item under the square root. So I was saying let u be equal to 1 plus t square. Because we know that there's that t square there, with this kind of u substitution, you must remember that in the place of t square, we will be making t square the subject, will give us u minus 1. But whichever way we go, we need to get du, which will be giving us 2t dt. If you differentiate there, and then you make dt the subject to take care of that. So our dt will be equal to du over 2t. So we can now substitute all this information into the integral. So if I go back to my integral, I will get my 36 pi outside, the integral from 0 to 1. Then as I've told you, in the place of t squared, I will go u minus 1. Then in the place of this t, it will stay like that because I know certainly dt will take care of that. Then 1 plus t squared is our u, and because of the square root, we put a half. Then dt is a du over 2t. Now you see that this t will be taken care of comfortably so. Then 2 will go outside, so that 36 over 2 becomes 18 pi. Then the integral from 0 to 1 of u minus 1 times u to the power half du. So you see that the variable has changed completely, but I've refused to change the limit. There are two options. It's either from this stage, you can also replace t by 0 so that your u becomes 1, and you replace t by 1, your u becomes 2. You can do that and change limit completely, or integrate in terms of u, then later we'll replace u by the value of u before we change limit. So I don't know which is easier. Maybe we need to change the limit completely so that when we're talking about u, the limit should also be the limit of u. So if we're doing that, it means we'll do that here. We've got the relationship is u equal to 1 plus t squared. So if we make u to be t to be 0, if t is 0, you see that if t is 0, this will tell us that if we put 0 there, u will be 1. And if t is 1, it means our u will be 1 squared plus 1, u will be equal to 2. So that will therefore mean our limit will no longer be 0 to 1, because 0 to 1 corresponds to t. For u, the limits are 1 to 2, where 1 is replacing 0 and 2 is replacing 1. So in that way, we know that you are now working in terms of u completely. So if we open the bracket, this multiplies, there you get u to the power 3 over 2 minus u to the power 1 over 2. So that is what you get. Then you can now integrate. So if we do our integration of ay, we get 18 pi into, when you integrate there, you get u to the power 5 over 2 divided by 5 over 2 minus the other one is u to the power 3 over 2 divided by 3 over 2 from 1 to 2. Then we substitute our upper limit, which is a 2 to the power 5 over 2 divided by 5 over 2 minus 2 to the power 3 over 2 divided by 3 over 2. Then lower limit, we are using a 1, so 1 to n power remains 1. So that is what we will be getting there. So we can now go to a calculator, knowing that on our calculator we are not going to use 18 for now. That is the way I prefer to do it, because 18 is a common factor. I'll just do what is in the bracket. So I get 2 to the power 5 over 2 is 2,5. Then I divide by 2,5. Then minus, I also take 2 to the power 1,5, which is 3 over 2. Then I divide by 1,5. So I'm done with this. Then minus, this item becomes 2 over 5. So I say minus 2 on 5. Then these two negatives become a positive. Then that becomes plus 2 on 3. So if I do that, I get 0,6 multiply by 18 pi times 18 pi. So if I multiply by 18 pi, that gives me 36,405. So our surface area, guys, is 36,405 unit square. So guys, I know it was a tough one, but that is how it is done. So thank you very much.